a pier is docking, a person standing at the end of a pier is docking a boat by pulling a rope at the end, at the rate of 2 meters per second. The end of the rope is 3 meters above the water level. How fast is the boat approaching the base of the pier when there are 5 meters of rope left to pull in? So here's our little dude. He's pulling right here at the end. Here's our rope. Here's the base. He is 3 meters above the ground pulling it in, correct? This is 5 meters of rope left. Here's our little boat. I'm totally an art teacher. Don't be jealous. Haters gonna hate. Anyone know how we could find the third side? Yeah. Trig, Pythagorean theorem, all of which are correct answers. Here's some water. Okay. So we're gonna do. I'm gonna label this one H. Sure. Label this one X. Actually, I'm gonna label it Y because it looks more like a Y, and label this one X. Right. So we're gonna have x squared equals 5 squared minus 3 squared. X squared equals 25 minus 9. X squared equals 16. Square root plus or minus. X equals plus or minus 4. It is an actual distance, so it's going to be 4, right? Meters. Now, we want to figure out a specific rate. We're given a specific rate. What formula did we use here? Pythagorean theorem, correct? So that is the formula that we're going to go with to derive. Because remember, related rates, you get a formula, and then you derive said formula, and then you get answers, correct? But we're not going to use SOHCAHTOA because an angle is not involved. Sometimes they do related rates with an angle involved. Then you would end up having to do SOHCAHTOA, and then you have to derive trig. So okay, it's not a big deal. Okay, but this one is Pythagorean theorem. Let's see what else they gave us. So they said a person is standing at the end of a pier, is docking a boat by pulling a rope at the rate of 2 meters per second. So is that dh dt, dy dt, or dx dt? Pulling the rope. Where is the rope? H, Y, or X? Which one's the rope? H. So they gave us dh dt, and they're pulling in the rope. So what's it going to be? You're pulling a rope. You're pulling it in. Negative. They want to know how fast the boat is approaching. So is that Y or X? X. So they want dx dt. We agree? Okay. So we need to do Pythagorean theorem is our formula, which is h squared equals x squared plus y squared, or whatever you want to label them. You could label h as the rope, y as the height, the base is b. You can label them whatever you want, right? You just need to use the proper variable in the proper spot. So we have to differentiate this. That's not the hard part. It's remembering to put dh dt and dx dt and dy dt behind it, right? So the derivative of h squared, we use power rule, 2h dh over dt equals 2x dx over dt plus 2y dy over dt. Now, we could only be missing one thing. We have x, we have h, we have y. We need dx. We need to find that. So we need to have dh over dt, which we do. And we don't know dy over dt. But we need to know it. Anyone have any idea what dy dt would be if it's a person standing here and this is 3 meters and they're pulling on a pulley? What is the changing rate of this pull? 0. It's a pole. It's a stagnant object. It can't change rate. It is 3 meters, right? It has no changing rate of height because it's always 3. So you have to watch yourselves. We're going to do a ladder question. What is the changing rate of a ladder that's x meters. It's going to have no changing rate, right? It is that. It'll slide down, it'll slide up the wall if you're pushing it up the wall, but it's not going to get longer or shorter. So you have to watch yourself with these ones. Often one of them is 0. So they're not going to tell you that, but it's the object that isn't changing. So this is a pole. There's a pulley on it, and there's a dude here pulling on said pulley. It's really long legs. Yeah, this is Gavin. Sorry, Gavin, you have really long torso. Long torso. Yeah, he's actually kind of in the water too. I don't know. He's just so aggressively tall. We just didn't know what to do with him. So, really short legs. Sorry, buddy. You've got really short legs. It's okay. Yeah, kind of lanky. All right. So, dy over dt equals 0 meters per second. Right? Okay, let's fill in what we know. So we get 5 meters. And then 0 meters per second equals 2 times x, which is 4 meters, times dx dt, which we don't know, plus 2, and y is 3 meters, and dy dt, why did I put a 0 here? Anyone? Bueller? It's a negative 2.
Yeah.
So sad. Yeah. This one is 0.
Yeah, it's negative.
So this one cancels.
Boom.
She gone. This one is 10 times negative 2. So negative 20 meters squared per second equals 8 meters times dx over dt. So we're going to divide by 8 meters. We're going to divide by 8 meters. Right? Dividing by 8 meters over 1 is the same as multiplying by 1 over 8 meters, the reciprocal. So we're going to get negative 20 meters squared over seconds times 1 over 8 meters. That cancels that. You take a 4 out of each. So this would be a 2, and that would be a negative 5. Equals dx dt. So then we get dx dt equals negative 2.5 meters per second. Boom shakalaka, just like that. So fun. Super fun.
Oh.
All right. Okay, in the textbook, you guys are going to try this one. Does this one work? 20 and 31.